Okay, hello students. So in this video, as promised, I will tell you about point of inflection. Okay, so a point which separates a convex and a concave sections of a continuous function is called a point of inflection. How do you find a point of inflection? If f double prime is equals to 0, or if your f double prime c does not exist, and if the value of f double prime c changes sign, then CFC on the curve is a point of inflection. Okay, changes sign means either it's from positive become negative, or from negative it becomes positive signs. Okay, and for point of inflection, not all f prime c equals to 0, but f double prime c must be equals to 0. Okay, so this is how to prove a point is a point of inflection or not. Let f be any function and CFC is a point of inflection if f double prime c greater than 0 for AC and f double prime c less than 0 for CB, or B, f double prime c less than 0 for AC and f double prime greater than 0 for CB. Means it changes sign. Okay, the greater than 0 means positive, change to negative, and here from negative is changed to positive. Okay, so your point of inflection is this C. The video, I have skipped this question for the inflection point, okay, because I said we haven't learned it yet. Okay, so let us see how to find the inflection point for this example. In this example, in the previous video, we have already found the maximum and minimum point. Okay, we have already determined the maximum and minimum point for this function. In this video, however, we are going to look into the inflection point only. Okay, so again, if you want to find the inflection point, you have to find when your y double prime equals to 0. So before we find y double prime, you find y prime first. Okay, and then our y double prime will be 2x minus 1. So we equate this 1 equals to 0, then we have x equals to 1 over 2. Okay, so this may be our inflection point, maybe. Okay, if x equals to 1 over 2, then you have to find your y first, which is y will be okay, so I find here 47 over 12. So I have 1 over 2, 47 over 12. Is it inflection point? The question is, okay, so we have to see either the y double prime changes sign. Okay, let's say I have x equals to 1 over 2 here, so I have to find a point before and after x equals to 1 over 2. Let's say I choose x equals to 0 and I choose x equals to 1. Okay, so this is the value of y double prime. So this is what we want to determine, either it's inflection point or not. Okay, so my y double prime 0 is 2, 0 minus 1, which is negative 1. So this is negative. My y double prime 1 is 2 times 1 minus 1 will be equals to 1, which is positive. So obviously it changes signs from negative to positive. Therefore, we conclude that 1 over 2, 47 over 12 is a inflection point. Okay, next example. This example is a trigonometric function. Given y equals to 2 sin x plus cos 2x, find if exists the inflection point, maximum and minimum points using second derivative test. Okay, so in this question, it asks us to find all the points like inflection, maximum and minimum. Okay, so let's solve the example 1, y equals to 2 sin x plus cos 2x. So as usual, y prime first. and then y double prime okay. So let's find for the inflection point first, which is y double prime must be equals to 0. So what we have is negative 2 sin x minus 4 cos 2x equals to 0. So we have to find the roots x. Okay. Okay, so I have a trigo identity. I will use this trigo identity, which is cos 2 theta equals to 1 minus 2 sin squared theta. Okay, this trigo identity to substitute the value of cos 2x. So I will have negative 2 sin x minus 4 and then this one equals to 0. Okay, so if I let my u equals to sin x, I will have negative 2u minus 4 plus 8u squared equals to 0. So this is a quadratic function. Okay, so just use your calculator. You will find u equals to 0.8431 and u equals to negative 0.5931. Okay, however, our variable is not u, our variable is x, so substitute back means this is our sin x. Okay, and then the x is arc sine, which is again, use your calculator and don't forget to change your setting to radian. Okay, so we'll have here 10030 and then the other one is will be equals to negative 0.6349. remember, radian. So this is the value of x. How about y? If my x equals to 1.0030, then my y is 2 sine 1.0030 plus cos 2 times 1.0030, which is 1.2646. Okay, and then if my y equals to negative 0.6349, sorry, not my y, my x, okay, then my y will be I have here negative 0.8897. So I have 2 points, okay, which is 1.0030, 1.2646, and negative 0.6349, negative 0.8897. Okay, is this our inflection point? Again, you have to test for the sign, either it changes from negative to positive, from positive to negative, or neither. Okay, let's say I test the point here. Test for inflection point. I have x equals to negative 0.6349. This one is the one that I want to test, and then I have x equals to 1.0030, also the one that I want to test. So I have to find the value before and after this so-called inflection point. Let's say I choose x equals to negative 1 here, x equals to 0 here, and x equals to, you can choose x equals to 2, okay, but that's too far from 1. Okay, I choose x equals to 1.5. Let's see. Okay, so when my y double prime equals to -1, I will have, where's your y double prime? Okay, this one is the y double prime. -2 sine -1 minus 4 cos 2 times -1, which is, I have 3.3475. Okay, so I just say it's positive. And then it's my y double prime equals to 0. I will have, again, just substitute the value. I will have -4, so negative here. And if my y double prime equals to 1 over y double prime 1 over 5, I will have 1.9650, which is positive. So it changes sign from positive to negative and then positive again. So we conclude that these two indeed is they are an inflection point. Next, we are going to test for critical point, either minimum, maximum, or neither, using both tests, first derivative test and second derivative test. Okay, first of all, let's find critical point. Okay, which is y prime equals to 0. Our y prime just now is this one, 2 cos x minus 2 sin 2x. Okay, so again, I'm going to use trigo identity. So in here, I will use this trigo identity, which is sin 2x equals to 2 sin x cos x. So I will have okay, so factorize. Okay, I factorize the cos x, or 2 cos x. We'll have 1 minus 2 sin x equals to 0. Therefore, this 2 cos x will be equals to 0, and 1 minus 2 sin x also equals to 0. From here, I have x equals to cos 0, and from here I have x equals to arc sine 1 over 2. So just use your calculator. You'll find here x equals to pi over 2, and this one x equals to pi over 6. Okay, so again, if x equals to pi over 2, your y will be equals to 2 sine pi over 2 plus cos 2 pi over 2. Okay, use your calculator. You'll have 1. And if your x equals to pi over 6, and then again use calculator, you will have 1 over 5. So your critical points, you have 2 critical points here, which is pi over 2 1, and pi over 6 1.5. Okay, next we are going to test either these critical points, minimum or maximum, using both tests. Okay, let's say first derivative test first. So I have x equals to pi over 6 here, and then x equals to pi over 2 here. Okay, so find a point before and after each of these points. Let's say I choose x equals to 0, and then this one I choose x equals to pi over 3, and then this one I choose x equals to 2 pi over 3. Okay, so this is our critical point, this is also our critical point. So y prime 0 will be Where's your y prime? 2 cos x, 2 cos 0 minus 2 sine 0, which is 2. So this is positive, so the slope increasing. Y prime pi over 3 will be negative 0.7321. Okay, you can try this. Okay, just use your calculator. So this is negative, the slope is decreasing. Next, y prime 2 pi over 3. Okay, I also have 0.7321, positive, increasing. Okay, so from the pattern we can look. Okay, we can see that the x equals to pi over 6 is maximum. Okay, and then the x equals to pi over 2 is a minimum. Okay, let's compare our results here with the second derivative test. Is it the same? It must be the same. Okay, so y double prime, remember the second derivative test just tests for the critical point. Y double prime pi over 6 is, what is our y double prime? Okay, let's see. Y double prime is negative 2 sine x, negative 4 cos 2x. So negative 2 sine pi over 6 minus 4 cos 2 times pi over 6. So I have here equals to negative 3, which is less than 0. So we have maximum at pi over 6, 1 over 5. Okay, and then if my y double prime pi over 2 equals to negative 2 sine pi over 2 minus cos of. So I have here equals to 2, which is greater than 0. So I have minimum at pi over 2, 1. Okay, let's compare our answer. So it's maximum here and it's maximum also here, it's minimum here and it's minimum also here for both tests. To find the inflection point of the curve fx equals to x to the power of 3 minus 3x squared plus 5. So the answer is 1 over 3 and it is an inflection point. Okay, the example 2. So this example just want us to find the inflection point. So f prime and then f double prime equal, this f double prime equals to 0, then I will have x equals to 1. So if x equals to 1, the f1 will be equals to 1 to the power of 3 minus 3, 1 to the power of 2 plus 5, which is equals to 3. So we have 1, 3. So is it inflection point? Okay, so we test for the sign. So I have x equals to 1 here. Let's say I choose x equals to 0 and x equals to 2. So is it the inflection point? F double prime 0 is 6 times 0 minus 6, which is negative. And then f double prime 2 will be 6 times 2 minus 6, which is positive. Okay, so it is indeed 1, 3 is an inflection point because the f double prime changes sign from negative to positive. Last example in this inflection point topic. Given y equals to 3x to the power of 4 minus 4x to the power of 3, find if exists the inflection point, maximum and minimum points using first derivative test and second derivative test. Okay, so let us solve example 3, this one. Y prime is 12 x to the power of 3 minus 12x squared. Okay, so let us solve for inflection point first. Equal this equals to 0. Then I will have 12x 3x minus 2 equals to 0. So here x equals to 0 and here is x equals to 2 over 3. So again we have to find a point. So if x equals to 0, then y will be equals to 0 as well. Okay, and then if x equals to 2 over 3, y will be equals to negative 16 over 27. So first point I have 0, 0. Second point I have 2 over 3, negative 16 over 27. So I have to test whether this point is an inflection point or not. Okay, so x equals to 0, let's say here, x equals to 2 over 3 here, and then y double prime here. Okay, let me choose x equals to negative 1. In between this one, x equals to 1 over 2, and then I choose another one is x equals to 1. Okay, so y double prime negative 1 will be 36 negative 1 to the power of 2 minus 24 negative 1 is 60, which is positive. Okay, y double prime 1 over 2 is, I have here negative 3, y double prime 1, I have here 12. So again it changes sign from positive to negative and then positive again. So both 0, 0 and 2 over 3 negative 16 over 27 are the inflection point. Okay, we have solved for the inflection point. Let us now solve for the minimum and maximum. Okay, so I have y prime just now is equals to 12x to the power of 3 minus 12x squared. Okay, let's find the critical point. So 12x squared x minus 1 equals to 0. So factorize. Okay, then I have 12x squared equals to 0 and x minus 1 equals to 0. So here x equals to 0 and here x equals to 1. Again 2 points. Okay, we have test just now that if x equals to 0, then we have y equals to 0 as well. Indeed it is an inflection point. Okay, if x equals to 1, then our y will be equals to y 3 1 to the power of 4 minus 4 1 to the power of 3, which is negative 1. Okay, so here is 1 negative 1. Okay, first derivative test first. So I have x equals to 0 and x equals to 1. Okay, so this is critical point, this is also critical point. Okay, let me choose again x equals to negative 1 here, x equals to 1 over 2 here, and x equals to 2 here. Okay, so y prime negative 1 will be negative 24, which is negative, so your slope will be decreasing. Y prime 1 over 2 is negative 3 over 2, which is again negative, so your slope will be decreasing. Y prime 2 will be 48, so this one is positive, then your slope will be increasing. Okay, so if you see here, okay, in your critical point x equals to 0, you have a pattern of decreasing again. Okay, so if you look into the first derivative test, okay, we say that x equals to 0, or not your 0, which is the point 0, 0, is neither max or min. Indeed, it is actually, we have proved that it is an inflection point. Okay, and then the x equals to 1, which is 1, negative 1, is a minimum point. Why is it minimum? Because it's decreasing and then increase again, so this is a minimum point. Okay, so let's use second derivative test to support our results. Y double prime 0 is actually 0, okay, which indicates the test failed. Y double prime 1 is equals to 12 greater than 0, means we have minimum at 1, negative 1. So the answer support each other. Okay, so we have finished with all the examples. You can do this tutorial later. Okay, please do the tutorial, and if you require the answer, do message us, your lecturers. Okay, and then there's another question here. Okay, and then we have finished with our chapter 3. Till the next video. Thank you.